Okay, so hello everyone. Okay, so this is the chapter on plane geometry, topic 11. Right, so we are looking at part 1, which is triangle theorems. Okay, so actually the point of this lesson is that there's actually nothing really new that you are looking at. It's basically a combination of what you have learned before, including proof of congruent and similar triangles, as well as the relationship between parallel lines. Okay, you will be encountering something new in this lesson, which is called the midpoint theorem. Okay, so let's go on and look at the next slide. Okay, so similar to algebraic proofs where we convince the reader when we are showing relationship or proving shapes, basically we're trying to show that either we are proving congruency, we're trying to show that two angles are equal, or we're trying to show that two sides are equal. What we always do, we have to write certain statement and indicate our statements with reasons. Okay, for example, if you look at this triangle, you will see that AB is equals to AC, right? But every statement has to come with a reason. If, for example, if we know that AB is equals to AC, right, now what's the reason? The reason is because triangle ABC is an isosceles triangle. Okay, angle ADB equals to angle ABC, which equals to 90 degree, because AD is perpendicular to BC. So with every statement, you are writing a reason, and the outcome is to show that triangle ABD is congruent to triangle ACD. Alright, so you have the third one, which is AD is a common side. So you have actually showed that a pair of corresponding sides are equal, a pair of corresponding angles are equal, a pair of corresponding sides are equal again, right? So you are actually using the RHS. Okay, you are actually using the RHS. Okay, because you have showed basically AB, AC, you have showed 90 degrees, you have also showed the common side. Alright, so this is basically how the procedure of a simple proof will be done in showing congruency and similarity. Okay, so you can see that for part 1, triangle theorems, right, how do we apply congruency and similarity tests in geometrical proofs? These are the questions we ask ourselves. And something new here is you will be looking at a theorem called the midpoint theorem. Okay, so the midpoint theorem will enable us to again determine certain relationship between triangles and sides. Okay, so let's recall a few things. Number one, if you learned this in junior high 1, you know that when you study parallel lines, right, there are certain properties between the angles that allow them to be equal or supplementary. Alright, so for example, if you look at angle A and angle B, right, these two angles, they are equal because of vertically opposite relationship. So when we write them down, A equals angle B, we have to make sure that we write down the reason vertically opposite angles. Okay, and this line is what we call a transversal. So when two parallel lines are parallel and they are cut by a transversal, we also have angle A to be equal to angle C. Alright, the reason is because of corresponding angles. Okay, so the reason is corresponding angles, and you can see that another way to remember corresponding angles is that it looks like a letter C. Okay, just like how corresponding angle starts with the letter C, and vertically opposite starts with the letter V, just like how in the question also diagram looks like a letter V. Okay, the cross alternate angles are equal, so you can see that angle B is also equal to angle C. Okay, angle B and angle C, they are equal, and in alternate angles you can see that it basically looks like a Z shape. Okay, looks like a Z shape. Okay, the interior angles are supplementary, so angle B and angle D, they are supplementary. Now the meaning of the word supplementary, as I have told you before, is that they angle A and B, angle B and D, sorry, add up to 180 degrees. Alright, so these are the relationships between intersecting and parallel lines. Remember again, that these are the properties that you learn: vertically opposite, corresponding, interior, and alternate from junior high 1. Okay, now in junior high 2 and 3 we studied a few names of certain lines and triangle. So the first one is what we call an angle bisector. Right, an angle bisector is a line that bisects an angle, and you can see that BD here is the line, is angle bisector of angle ABC. As you can see that BD basically cuts angle ABC into two equal angles. Okay, and you have ABD equals to CBD. So when the angles are equal, what we do is we always try to label them with the same number of strokes to show that they are equal. The second one that we're going to talk about is the perpendicular bisector, which is also a line segment that bisects, and not only does it bisect, it also is perpendicular to a given line segment. So you can see that AB is cut into half by the line CD, which basically cuts it into two equal parts, and it also cuts at a 90-degree angle. Okay, so the line CD is what we call a perpendicular bisector because it cuts AB into two equal parts, line segments, as well as cutting at a 90-degree angle. Okay, so the third would be the isosceles triangle, which you can see is basically a triangle with a pair of equal sides or a pair of equal angles, right? An equilateral triangle is a triangle with all sides equal. Okay, so these are just some of the common terminology that you have studied before. Okay, so why do we need to know this? Is because, okay, certain times you may be asked in the lesson to be proved that certain triangles are isosceles, certain triangles are equilateral. Okay, so you need to know the definition of the triangles. Right, for congruency test, recall that you have studied the following tests. Alright, for congruency test, there are a total of 5. Okay, the first one is side, SSS. So using the SSS test, to congruency, you need to show that corresponding sides are equal. Okay, using the ASA test, you need to show that angle A equals to angle X, angle B equals to angle Y, and AB equals to X1. So this is the ASA test. AAS, okay, as you can see for itself. SAS here, the angle must be an included angle, meaning that if these are the two sides that we are talking about, the angle must be in between the two sides. Okay, for RHS, basically the angle here is 90 degree. So just like what we have done just now, we showed that the hypotenuse H, we showed that a side S, we showed that the angle, right angle, F equal on both sides. Okay, that's how we show the congruency test.